Hi, my name is Mohamed El-Geish. I'm Director of AI at Cisco, and I'm here to talk to you about the AI industry, some predictions about this decade. So I want you to imagine if in 10 years from now, you're sitting and looking backward at the last decade, what things would AI bring to you? How did the AI industry change? I think that it's actually very hard to make predictions, especially about the future. Some wise men said that, and I think that it's true. And I think the best way to do this is actually to go backward and think about like how the past was for AI and try to make some predictions given the history of AI. But one thing for sure about this talk is we're not gonna mention anything about artificial general intelligence. Sorry about that. So let's go quickly through the past and talk about the three main pillars the ingredients that make up an AI solution. And I think this is fairly important. If you think of how the research and more importantly here, the talent, the people element has changed how we use the data and the compute power that we have available at our hands these days. These three ingredients have changed the way we do AI, and they enabled much more scenarios than ever thought before. The reason why the research or the people element is in the middle is it actually connects both. And it's super important that you have the right folks on the team that are working on these AI solutions. They know how to wrangle the data, they know how to utilize the compute, and they know how to come up with new algorithms and new techniques to make it much more efficient. So let's start with compute. I'm sure you're all familiar with this graph and how like Moore's law has changed the way we think about compute over time. I think somewhere there in the left bottom corner, you can see one of these processors that brought us to the moon. And on the top right corner, your phone and your pocket has more processing power than that machine. And the reality is, even though like Moore's law might not be advancing as fast as it used to be, we still have a lot of improvements, especially using ASIC or accelerators, generally speaking. So we have GPUs now for training and inference and other kind of chips that you can use. Like you see announcements every day that are mind-boggling in terms of speed and how many operations per second they can afford to calculate. And the nice thing about it is you can also like have parallelism in the way you're thinking of your machine learning algorithm. So you can stack a lot of these together and you have a supercomputer that does a lot more calculations than ever before. So one thing I usually encourage people who are entrepreneurs and innovators is to think of like in 2 years and 5 years, what hardware would be there and how can they make use of that? And think of the things that were impossible due to hardware limitations and how can they basically think about the future in 5-10 years, given that hardware progression. The second one is research and techniques, algorithms. If you think about how it all started 1300 BC, and we have this abacus, maybe the first computer, if you may call it that. And then I try to do this to scale, but it's really hard. In the 1950s to 2000, you can see a lot of progress for machine learning and AI. And it started maybe with the Turing test, the perceptron, we got backprop, and other techniques that made it so much easier, especially in the resurrection, if you may, of neural networks and deep learning, when we have like algorithms like Relo that made the training much, much faster and so on. All of these things happened because a lot of talented people who are really focused on making things more efficient and more capable than ever before. And the more recent advances are actually just mind-blowing. The way we have been seeing updates of progress in NLP specifically and other techniques, like all these Muppetware pre-trained models that allow you to like stand on the shoulder of giants and you don't have to like train on the entire internet. People are sharing these advances for us to like go and use and of course contribute to, and you can fine tune them. You can post them back to the community and like really like figure out the task that you want, and there should be something out there that could help you. So the collaboration has been helpful, but also the emergence of a lot of digitization. This is maybe a more personal take on my footprint, my digital footprint. So, and then, in the 80s, there was almost nothing in terms of like data about me. There might be some data that's not digitized, but not much out there. And then in the 90s, with the kind of, getting a PC and having this isolated machine for the most part, maybe there was some internet connectivity that collected some information or some data about you, but not as much as we see today. So there's some footprint there, but it's not as interesting. And then we get an explosion of digitization in the 2000s. You have a lot of interesting scenarios, devices that are connected to the internet. You got your laptop, your iPod, your iPhone, and even your landline became digitized. It's now a VoIP phone that has some trail. There's some data about like how you use these things. There are all signals coming out from these devices, and now we can do some interesting things connecting these dots. Even your games are connected to the internet, and maybe you can draw some insights about what games you like and recommendations of your music taste and so on. And then in the 2010 decade, that decade has seen the IoT revolution. So a lot of things, came in the last 10 years that were just extremely impressive in terms of like everything would be connected to the internet and emits signals and emits some interesting data series that could be used in analysis and insights. And really the, relatively small circle there from the 2000s can fit in a small corner in that big bubble of the 2010. So just imagine how the 2020s will bring a lot of like innovation and digitization that's ever than before important. And also, it's not just the individual components or the individual devices that are producing all of these data points. It's also the second order effect. So interesting linkages between different services and different devices talking to each other and collecting interesting data that can help you do more things than ever available to you before. So I made this chart. It's actually a real chart from my faucet, which is just internet, connected because it has Alexa and it can, basically dispense a specific amount of water based on my voice commands. But I just thought about this. It gives me a dashboard of my consumption of water, and I thought about like companies that actually need access to this data, so it has access to my device to know more about like my consumption, and I can basically talk to Alexa and ask like how much I've used in past month. So can other companies use that data and maybe send me recommendations? I'm looking at Amazon here, for example, like using that data with my permission, of course, to understand more about my habits. So here, it's an interesting thing that you can see in April, something's happened. There's a spike in the data series. So Amazon, with their data mining and machine learning algorithms, can figure out like what could the reason be. And connecting multiple dots, you can actually kind of interpolate what happened. In this case, I had guests in my house. So maybe Amazon can actually recommend for me certain things that I need for guests in the retail website. And the same thing here with my dog. If you have a sensor on the dog that tells you like where they are at all times, it has GPS, and it has also an activity monitor. If it's connected to another device that requires access to such data, could they link these data sets and figure out like, okay, when my dog is doing a great job, maybe it's time for buying treats and I get some discounts or offers on these treats or something of that sorts. So really the important thing here is there are a lot of connections that are happening. But that also begs the question of data privacy and like how and who owns the data and how can we actually make use of such data for the things that we allow others to use it for. So what if I don't want to make these connections? And I think that is a good segue for predictions. You've seen a lot of interesting things that have been happening in the last decade about privacy, and rightly so. This is a good move that we have laws that are very like digitized, or they are interesting in terms of like digitization of data and how we use the digital versions of ourselves, basically our data sets that are basically like, telling a lot of information about who we are and what we do. So you saw GDPR coming in, or happened in EU, but also we have some other laws in California and Brazil that are newer than GDPR, but just as interesting in terms of like how the sub-processors of data have like basically tell you what kind of data they're collecting and how they're using it. And at the end of the day, you're the owner of such data and you have full control over them. So that's a good thing. We need good laws. And that's here, the word good is an operative word. That's actually what I would like to highlight, that we need to participate in these kind of regulations, how they're formulated, and make sure that the lawmakers actually understand all of these technical terms that we've been using and how they're applied and so on. And the other thing is like data could be weaponized. We've seen a lot of talks about this in terms of like elections and other uses of it. So we gotta be careful about how we collect and maintain such data sets and who has access to them. And finally, there was a prediction that might be true, actually, that one of the propositions in California this year is to create an agency that's basically a data privacy agency, and we'll see how this goes. But I think, in terms of domains that require such understanding of the data and like also understanding of the models that make use of such data, out of all of these domains, the health and legal domains will be the top of mind for me. Like you need to understand when a judge is making an AI or ML assisted decision about parole, how can we make sure that they are well explained, they're unbiased, they're transparent, and this is going to come maybe like soon. And I think overall, just having these things will protect us from having another Cambridge Analytica. Maybe another one will happen, who knows, but the idea is like having these laws will make it much harder. Another prediction is really about how we use the data without labeling. So if you think today of like a lot of the data, a lot of the applications that use machine learning and the data used to actually build these systems are supervised, meaning that there's a human force, a lot of people like workers, they actually sit down and experts and figure out like the mapping between the input and the output, and basically tell the machine how to recognize these patterns, so they label the data sets. But the idea of like using self-supervised learning is extremely important because there's so much data out there, too much actually of it to label, right? It's going to be super expensive if we have to rely on purely like supervised methods. And also it has to do with privacy, as we talked about like earlier. If only machines can see your data and can figure out what to do with it, then we're in a much better way preserving that privacy. And we already saw a lot of wins in NLP. So all of these like new models you hear about, like BERT and so on, they're basically using the input to create more, label. Like one of the examples here, like BERT is masking some of the words in the sentence in the input and trying to predict what the word was, or 15% of the words in a sentence. And the nice thing about this is, it's a hot research area. There's a lot of interesting things. You see a lot of like conferences, like NeurIPS has a workshop on SSL and so on. And that kind of interest actually generates good results. And I think we're going to see a lot of improvements in that area. And I think Jan LeCun is on top of that field and pushing hard for it, as you can see. Another interesting way of doing deep learning, it has to do more with the algorithms and the techniques rather than the data, or solely like the algorithms. In this case, it's what we call like system 2. It's a different way of doing reasoning about the world, and that came from a very interesting book that I highly recommend for everybody, Thinking Fast and Slow by Daniel Kahneman. And it basically says that there are two systems that we use when we're thinking. One that's more of like a reaction, like call it the lizard brain, that's responsible for things that happen maybe within a second. And then another one which has more to do with meditated thinking, like things that you reason about and take your time to think about. And we saw a lot of work coming from Benji's lab. Last year specifically, there was a paper at the NeurIPS, and before that, multiple talks about that kind of system two approach to the world of deep learning. And the idea is it's also going to use much less data sets or much less data points, because the model actually learns to make these high level abstractions about the world. It's akin to a child learning, a child can see a dog multiple times or multiple instances of a dog, and they can easily generalize even if the dog is partially seen behind an obstacle, or they're looking at it from a different point of view. They know what the dog is, even though they only seen a few examples. And that's the whole idea. The challenge today for a machine learning system, especially envision that you have a lot of examples to teach the machine how to learn. So hopefully by doing this, the models will actually require less data, significantly less data. And the other thing which is also nice is you can take these components and think of them as Lego bricks, and you can actually take them and make them work in other contexts, in other tasks, because they can reason about the world. So they don't need to be specifically trained for a task, but they can just understand representations about things in the world, and they can integrate with other novel tasks. I think in another way of thinking about machine learning, there's AutoML, and I think of this as a way for us to do machine learning that is more democratized. So now we are maybe thinking more and more about representation learning and automatic learning of features. So recently we just dump data, and of course we pick the right amount of data and the right kind of representations, distributions of data, and let the machine learn the representations that are easier or more conducive for learning the task. But before that, there was feature engineering. There was a lot of manual domain expertise needed to actually do the task. And right now, if you think of AutoML, it's true end-to-end. So instead of us sitting down and creating the architectures for the models and choosing the hybrid parameters and tuning them and then coming up with these tricks, and maybe our brains are thinking in a limited capacity when it comes to these different combinations, and we don't basically rely on the machine choosing these things for us. But what if we can't? What if we can just tell the machine go figure out in that search space what is the proper or the most optimal way of coming up with a model for this problem given the constraints. And we are kind of doing labeling for it right now. We're telling the machines here's some of the good examples that we think are proper for these kind of tasks, and they can use that as the seed for building these machine learning models. But it's basically automation of machine learning. And the nice thing about it is it can open up the door for a lot of new domains that require expertise that are not as dominant today, where or machine learning is not actually as well adopted today. So if you think about it, for the most part, machine learning has been dominant or maybe more prominent in tech. So of course you have all the tech companies that are doing machine learning in interesting ways, whether it's recommendations, search, Facebook, Google, Amazon, Cisco, all these companies, LinkedIn, have been working on interesting machine learning problems. I cannot mention all of them, but you have the G Mafia and you have Microsoft as well there. I cannot miss this one. So a lot of interesting companies are doing these machine learning solutions. But if you think about it, they're still in the IT kind of software realm. And of course, we have bioinformatics. We have now some of the interesting things happening in manufacturing and so on. But really, we're not there yet in all of the domains that AI can help with, right? So maybe we're doing some in logistics and planning, and maybe we're doing some in agriculture. But there's so much more that literally any place you have need for automation, for the most part, can be improved. And AI is not there yet. So we're really at the cusp of that, or at the beginning. This is just scratching the surface. And having AutoML will allow us to go and let the business users, that the software engineers who might not be as trained on understanding the intricacies of how to build models. You maybe need to understand the data science behind it, understand how to do evaluation, understand how to do integration of these systems. But the main things of building the representation and the techniques needed to build models could be automated using AutoML. And this is a new field. I see a lot of startups are tackling that, which is a good sign. I think it will open up the room for a lot of other businesses on top of that. So the idea is you have maybe a service platform where you put up your data there, you upload your data, and you kind of give it a definition of what you want to be done, and you have a model via an API that works just perfectly for that use case. To some definition of perfect. The prediction about NLP, I think it came from noticing a trend in, of course, transformers and the Muppetware pre-trained models we've seen. A lot of tasks are very interesting in NLP, especially when it has to do with language. Things tend to get a little bit ambiguous and complicated, and I think it's going to catch up with vision. We see a lot of interesting metrics coming in. I think the metrics need some improvement. So, whether you use some metrics for summarization and translation that look at overlap, or maybe they're not as close to reality of what you want to capture as possible. I think there is a lot of interesting work that came from Salesforce on this. The Einstein team published some paper about using factual correctness. The Google team as well published something about chatbots. So Mina is a great indicator of that. They came up with new models for specificity and sensibility in chatbots and message handling and dialogue management and so on. And I think it's maybe the decade where we're going to see a lot of summarization improvement. Hopefully it's going to be a solved problem in our lifetime. And I think it requires a lot of cross-pollination for NLP to catch up with vision. We saw this actually very interesting cross-pollination before when you get some ideas from speech, which is kind of similar in a sense that you're dealing with sequences and dealing with a lot of ambiguity there as well. But you can also see a lot of cross-pollination from vision into NLP and vice versa. One of the examples we saw recently was GPT model used for vision instead of convolutional, which is, if you don't see the irony of this, I think it's really interesting. There's some interesting ways you can use one technique or one method into another field that could have been just forgotten about or maybe never thought of in that other field. So hopefully this will have some interesting intersections or pollination that we use for advancing the field. And one of the interesting things that I saw from Persilian's group is teaching NLP models abstract concepts. So basically think of the world as a composition, and it can break it down into smaller and smaller units. So if you take a room, for example, maybe a hall which has a lot of chairs, and you take one chair and you break it down to maybe a surface and a panel and 4 legs, and you define what each of these components are until you figure out maybe some atomic part that is harder to break down to smaller parts, and then you define what you can do with it or how you can use it, and then the machine can start understanding these concepts. They're abstract, but they can understand definitions, and they build compositions out of these, and then you can now manipulate that world. And that's interesting in in computer-aided design and other things that can actually benefit from AI, when you describe, for example, a design, and then the machine can draw it for you automatically. Actually, I'd be missing out if I did not mention GPT-3, and that's one of the most hyped technology advances in NLP. And we saw some of these actually examples I mentioned, but not the exact same techniques, but basically taking some text and creating a website or creating a design. That's something that has been done in 2020. So another prediction I have is really about a new breed of data. Think of the data we have been collecting prior to like the data sets used in machine learning as operational data. So like these are the data sets that you use like for taking care of business, tracking, what happens on your system, data that you need for like, users, signups, and just user-generated data, that things that you do CRUD operations on, and maybe do some reporting, maybe some insights, analytics. But really, there's a new kind of way of thinking about data, in the sense that if you think of that old data breed as the stuff that you will use in Excel sheets, maybe in business intelligence, SQL, maybe OLAP, you make some cubes and you slice and dice by certain interesting dimensions and intersections. In ML, you think that this is going to be like more about learning from the data. So how can you actually think about that as a skill set if you're going to the workforce and you're trying to like figure out like what kind of skill sets do I have? I think everybody actually has to understand data. Just the same way when you have like a skill set that people require today, like you have to know Excel, you have to know SQL. I think almost everybody in the future has to understand what is machine learning, what do we do with data, why is it important to collect data, what kind of data do I need, how can I make use of this data, and then understand the possibilities that machine learning and AI bring to the table, but also understand the limitations and the non-deterministic nature of such techniques and such solutions. So I think of data sets as the new code, and basically it's a kind of funny way of writing code. Like you write some very little code that's almost like boilerplate, and you feed it a lot of data, and it learns from that, and it kind of tries to find patterns and find mappings and find interesting things. But you can also look at like how we build software as a stack, as an ecosystem rather. We have hardware for our software, and today I put a check mark on this one because we have been basically seeing nonstop advances in hardware accelerators just for AI. Like you go to any conference that talks about chip design, and I think at least half of the conference would be talking about like specifically deep learning accelerators and how can we make like matrix multiplication much faster for these kind of applications. And then I think there's going to be some more love for like math and probabilistic programming languages. So just the same way we have seen evolutions in the way we're talking about like low-level languages and high-level languages, I think it's going to be time for us to think more about the variable as a random variable and distributions rather than like the current like paradigm of thinking about deterministic programming languages. The same thing happened, like, just like we talked about hardware, we talked about like having like GitHub and before that like SourceForge and other repositories of code, and app stores where you can download binaries or download apps on your device and you could just run them right away. I think there's going to be a marketplace and some, of course, free places where you can contribute to data sets. You can see data sets to download and use. You can fork the data sets and like upload your own modified version. And more importantly, you can have second order effects data sets, whether for sale or just to contribute to open source. And the idea is like the same way we treat code today, where you have some notion of cleanliness and some notion of like popularity and like stars you have on GitHub and reviews and issues. All of this is required for data sets. Today, you might find some catalogs where you have data sets and you can buy them or download them if they're free. But I think it requires a more mature system, just the same kind of shift we've seen after GitHub and after like open source became much easier to operate and download or pull and actually work on and then contribute to because of like these kind of support systems and ecosystem components. Same thing has also evolved for licensing and understanding the licensing of data, rating of data sets, but also understanding what it means to actually try something. Like we can understand how to try an application today. Maybe like there's a freemium or there's like a time limit on it, but what does it mean to like try a data set before you buy it, right? What does it mean to like contribute back to the data set, and who owns the data, and like figuring out all of these things is a sign of maturity of this new code ecosystem. And just like the life cycle and the tooling we have for code has evolved over the decades, software is not like, you know, evolved in one night. It happened over a long time, and a lot of like lessons learned and best practices established. So the same thing, like how to debug existing deterministic code versus how to debug a non-deterministic machine learning based or AI based component or system. It's a difficult, you know, challenge. And the same thing applies for monitoring, explicability, and or how to explain what's happening, decision making, QA, and like, you know, statistical testing versus like, you know, unit testing, and all of these things that we had for a long time. And then just establishing the best practices. These are all challenges that I think are going to be maybe not solved entirely, but at least we're going to have some big steps in that direction, and into the right direction, I hope, for these kind of systems to mature just the same way we have like traditional software matured over time. So that's really how I think about it today, that we have somewhat mastered traditional ways of writing code and you know, kind of rule-based systems, but we're somewhat still clueless about how to like do the same thing for AI and data sets. Just think about it, like, you know, the systems that we have been building recently for deep learning specifically, because deep learning has a lot of interesting things about explainability, and it's more of like a black box for a lot of things. The theories do not match exactly, or didn't catch up yet with the empirical evidence we've seen of like non-convex optimizations working just well. And all of these things have been happening for maybe the past 7 years. So 2013 is, you know, the speech recognition and vision systems that started showing a lot of progress in using deep learning were the beginning of that revolution, or maybe a resurrection of it. And we have been writing code for much longer than that. And, you know, a lot of people wrote a lot of books about it. There's a lot of debates. There was a lot of dissertations, courses, and a lot of processes established long time ago. And imagine like the amount of man hours spent to build these like techniques and best practices and principles. So we're not going to, you know, start from scratch for AI. I think we have learned a lot of that kind of transfer learning from the traditional code, and we try to adapt to this new reality and understand that, you know, that theory has still like some room. The theory has to like catch up eventually with the empirical evidence and explain what's happening. But we also have a lot of interesting, you know, techniques that are trying to like maybe rationalize that. You know, like we have a lot of things that we can use today in our toolbox. A lot of smart people are working on that to make sure that we have proper life cycle of AI, proper understanding of models if we need such explanation, or you know, rationalization of the models. And we can also think of like the life cycle that it takes an AI system to mature, and how it, you know, its impact on like society and bias, you know, in terms of like fairness, differential privacy, all of the things that, you know, transparency, all of the things that you might not have to worry as much about a deterministic system, because you have tested, you know, everything, and you can basically look at the code and like figure out what's going to do with a high level of confidence. Even with pseudo random generations, you can still like, you know, guarantee some sort of confidence and understanding the behavior. Right now, we need to like hone that skill set and figure out like how can we train software engineers and AI practitioners to actually take care of the entire end-to-end system, and figure out the life cycle to make AI somewhat closer to like the process we have been used to for the code that we have been building for a long time. So here are the takeaways for today. I think overall that there's a new breed of data, and it's meant to actually build AI systems, which is different than the operational data. And it's important that we think about all of these predictions in the light of like what kind of skills that I need if I'm looking for a job in the future. What kind of skills that I need for my next career move, since like this is the direction we're gonna see a lot of companies moving towards. And if you're starting or investing in a new company as an entrepreneur, as an investor, as an innovator, what kind of things should you tackle? Like you want to see where the buck is going, and you want to skate there and figure out like how we can help maybe the ecosystem. How can you come up with new products that will run on hardware that's not built yet, but by the time you're done with your work, it might be the right timing for it. And of course, for anybody who's a professional today, how to prepare your business for what's there to come. So I think, my ask of you is help make AI as solid as, and also as mature as traditional software. This is on us. Contribute to open source. Maybe, figure out like something that can help others, either service, paid or free, it doesn't matter. This idea of having all of these ecosystem components, it will allow us to actually have a much better AI-based solution ecosystem than the current status quo. And I think this is a good room for us, like, a good venue for us to discuss these things and figure out like, what is next. And I think the best way to figure out what's next is you can build it. Let's build it together and figure out like, what the future holds by actually making it happen. Thank you so much.